Hey guys, welcome back to the channel. I have another interesting video, hopefully, working in a marine MEFI 4 coming from Montreal. Robert H, this is your computer. He actually overnighted this computer. He has a no crank, no start, no communication. So we first, as I normally do, we'll try to duplicate the concern of the customer here. So for that, I have everything pretty much as you see connected and ready to go in the bench. I'm using the Mark 50, which is, I created a harness that you will, if you follow the channel, you know what I'm talking about. This is a new harness and everything that I created for this setup. And the Mark 50 is this little tool right here. That is this simulator, and it's very capable. And I have the picoscope in order to read the injection in bank 1 and 2, and also the coil if we get it running. So let's first try to see if we can talk. So I'm going to get the Pico and the Diacom, which is the marine diagnostics that I use for this setup. All right, so let me power this on. We will see if this is working. This is a substituted value of a test light, so you guys can see it better for the fuel pump relay. So I'm going to put the ignition on. And now, sorry, the battery on, and now the ignition. All right, we have no fuel pump. That is already concerning. I can see only 160 milliamps of draw with the Mark 50. When these computers are working fine, I see like around 250 milliamps of draw, and that is considered normal. So 160 is low. It is coming on, but not fully on. And I can see the sensor ground. Let me turn this lamp off. You get to see the sensor ground and the 5-volt reference is active. So the 5-volt reference is there, but it's definitely not reading anything. So the voltages that we see right now on the injectors are just what this is a load box for coils and injectors substituted, right? So I don't have to have a real injector or a coil firing in here, so it can damage my electronics. Mostly the coils, not the actually injectors. But I can use one of these channels. Let me see which one is this one. Yeah, this is the blue channel. I can show you because you can see the readings on the bottom. I have a min and max on each channel. So I'm going to put just a needle in the front of this channel, so we can read the voltage. So right now the blue channel is reading 26 millivolts. So I'm going to touch on here to see what are we reading in there. And yes, we got 5 volts. As you see, 4.993 is the minimum, and 5.007 is the maximum. So it is definitely a 5-volt reference for the sensors. That's what that one is for, but nothing else. All right, so let me open this computer to see what we find. I'm going to flip it around just 1 second in the video, so you guys get to see. I'm going to read the numbers in here because it's probably a little too far for you. The numbers on this module, there is actually a unique number. The part number, which is very generic for a MEFI 4B, is 12584052. So that's the Delphi number for the MEFI 4B. But the unique identifier for this computer itself is the last digits after the A. So it's A as a letter, right? 32510011. That is a unique number that only this computer have. All right, so let me open it up and see what I found. So what we find, right? So I'll be right back, guys. All right, guys, I got the computer open. Yeah, you can see me from there. Yeah, I got the computer open. I'm going to show you the part number here now that I have it off. You can read that the last number 0011. Again, they're very unique. Yeah, 0011. They're very unique to his module. That's the only computer I was hoping to see. You know, maybe these MEFI 4Bs are very prone for the gel to go into one side and damage the connectors, which is it's hard to repair, but it's the less damage to the board as far as internals, and that is not the case in here. So I have, in my view, again, I'm trying to protect my information because I have seen many companies trying to copy what I do. So hopefully you understand that, but I'm going to tell you at least the readings. So as you see now, I have the computer open. I have the meter in there for you. You see, maybe better if I put it right here so it's not in your way, at least to see what I'm poking about. But camera, I'm not sure if I'm going right now. It looks like it's focusing in here and not in here, but you'll see the result. So we should have, let me just get myself into the microscope so I can see. Let me adjust this, guys, 1 second. To the height, perfect. That is very good for me. So we should have battery voltage in here. Got what? No, let me see. Oh, the computer is off, so that will make sense. Let me put the meter also. How can I do this? Because I need to see, otherwise I will have to be looking at what you guys are seeing. Give me 1 second, guys, to adjust this. All right, guys, I think I adjusted. So yeah, let me power the computer on. I can see the firewall reference and everything. So the computer is back on. So yeah, so these ones should actually read 6.3 volts in here. And we got 6.27, so that's fine. And here we should have 12.4 or so, like around battery voltage. I don't remember if I did this or with the other. So we got 12.6. So that is, those rails are good. Let me see what else. We got another. We got battery voltage here, 13.13. So that's fine. Here it should be the same. And it is. Here on this transistor should be around the 12 volts, and it's fine. Same thing on the other leg. And then we should have 5 volts in here. Let me just see. No, yeah, 5 volts onto this capacitor. 4.9. This is the very important. This should be 3.3 volts. And it is. So we got 3.3. So that's actually really looking really good for this computer. We should have 12 volts in here. And this should convert through the resistor to a 5 volts. Let me just see here. And it is. We should have 5 volts on this capacitor. And we do. We should have 5 volts in here. And we do. We should have 5 volts in here. And we don't. Okay, so we're missing one rail. That is actually looking good, guys. Believe it or not, this is actually a good hint and a good hope that I might be able to repair this computer. When I see voltages really skew, like and I start to have 6 volts in here, I get like 12 point something. That is a short directly under the 5-volt regulator and voltage regulator. This is the area right here. Yeah, it's going to be very hard with all this slide for you guys to see, but I'm in the voltage regulating area. So let me go over to the microprocessor, which you have in the microprocessor on the outside line. I should have 5 volts. And we do, and 3.3 in the center, which I think we will. Yes, so this microprocessor is in good shape because we got the correct voltages in here, and then the center should be ground. And it is ground, so those are good. So this is like actually looking really good. I'm not even know what's set up because he sent me absolutely no information with the computer. I'm going to have to contact him because, yeah, he has speed up the delivery, but I don't think I have a return address or anything from Robert, so I'm going to send that pretty quickly to him. But the first thing I wanted to do is check it out and see if I can actually make it work. So let me just, let me see one thing because I can do that here. Give me 1 second, guys. All right, so yeah, definitely this might be repairable. I'm still going to have to open the areas around the regulator and do my secret sauce, which is again secret. I forgot. I don't know if, I'm sorry, but I've been doing a lot of work during the day, so I don't remember if I did or not. So I'm going to get to or try to attempt to connect to the DICOM one more time. The computer is powered on, so I'm going to do that probably here better. Let me just see, because I think nothing changed. Yeah. So let me turn this off. All right, so ignition off. Ignition back on. Nothing happened. You can see the 5-volt reference coming back up in there. and nothing is happening. So, but you saw the power on the computer as far as the meter and everything. So let me attempt communication with Diacom. So I'm going to select, make sure, yep, MEFI 1 and 4. And then just attempt a communication, which I know it's not talking the way that this is it. I'm just trying to remember, this is for the customer. And for all of you that are also watching the video, this is what I do. I try to gather data, collect the data, show it to you so you can see that I'm duplicating 100% your concern. No crank, no start, no communication. The starter is completely separate from the computer on these boats. So you can crank and crank. It will never start because the computer is not talking. Yeah, there's no injectors, there's no spark. The computer is in complete control of that. All right, so guys, let me see what I can do with this. And if it, hopefully, for good news for Robert, I hope that I can make this work, but we'll see. All right, guys, I'll be right back. Hey guys, very good news. Robert, another successful repair. Let me just try it up. All right, so I got the computer connected. Let me just move you over to here. So let me first, yep. The fuel pump, you can see the light in there. Let me turn the computer off as far as the ignition. When I turn the ignition on, the fuel pump should do a cycle, and we can now see the cycling of the fuel pump. That is the first clue that we have a now good working computer. All right, so let me put the picoscope and the the Diacom. I'm going to disconnect from the Diacom and do a connection like I did before. So you guys can see now talking to it. All right, so computer is on. Now we can see detecting it. And I'm going to select mode 1. We have, we see 2 full codes in here in history. Pump low, VST open. Those are just, I don't know why it says pump low. We'll see, probably because it wants to see the computer running. Throttle position is in 0, so let me move that a little higher. Yeah, that was a little low. The computer has 661.5 hours. Calibration checksum is 4EDA. The rest, I don't play with anything in here, so let me just run it. All right, so now the computer is running. We are seeing 2 signals on the oscilloscope. So we have the EST signal, which is for the coil, and then one of the injectors. I always start that way when it runs, so we can see the actual computer running. Let me see what is the RPM right now, because I'm not sure what the RPM is right now. We are, yeah, very low, 152, so I'm gonna raise that. The RPM, so disregard that little signal, because when I press the button to raise the RPMs on here, sometimes I try to disconnect because it's kind of like cutting the signal off. I'm gonna go a little slower so that doesn't happen. 500, almost there. Okay, we're on 650 RPMs. You can see now the blue is the ESC signal and the red is channel B or injector bank B. We're supposed to be here getting around 2.3 milliseconds of injection. So let's see what we got in the oscilloscope. I can, measure that. Let me just see. Actually, let me stop the capture 1 second and let me measure the injection millisecond. Yes, with the cursors closely, right? So I'm just not going to go very, very precise. I can zoom in if I want to go very precise. Yeah, the exactly injection millisecond right now is 2.5 to 2.6 milliseconds, and the computer is looking for 2.3. So we're really, really close. It's a 5.7 liter. Not sure exactly what it is. I will have to ask Robert to see which boat is this. All I have is a MEFI 4B that didn't run. And for these ones, I don't really care too much because I do have everything to connect either way, 8.1, 4.7, 5.0, whatever it is, 5.7, sorry, 4.6, 5.0, 5.7, 7.4. They're all connections are pretty much the same as long as our MEFI 4. But everything is in good condition. So let me move over to the other bank of injectors. We can see very nice injection drivers. This is very, very nice to see a computer that has one activation per injector time. It's very common on these MEFI 4s when they have been running specifically over, many hours, that you see kind of like a second injection pulse very close, or sometimes even in the same time it gets activated. It doesn't affect much. Boats are, very forgiving on that. But this one is super nice and clean. So both bank of injectors running, the computer is working perfectly. Robert, this is, like I said again, a successful, 100% successful repair. I'm very happy that I was able to help you, and so quickly too, because in this case, it's nothing else I can do. I need to repair the computer because it's unknown, the results, until I try to repair it. But you can see everything now working fully operational. Let me turn the RPMs off again one more time. Let me get you back to that same capture. I'm going to turn the computer off once again. Power back on. We see the fuel pump coming on, and let's run it. And it runs instantly. You can see the injectors, and that's the reason why I use the oscilloscope in there, so you guys see the injection millisecond, and you can see the minimum and maximum for both channels. Right now we have 13.3 volts on the upper section of those signals, and then going almost to like 29 millivolts. I mean, that's pretty much pulling completely to ground, and that's very nice to see. So these both got to be running really good. It's very hard to know what it takes down. It could be a short in the harness or a short on the sensor to power. Very important, Robert, that you check your boat. I don't have any other history. Again, the only thing that was there was you see fuel pump open and ESC opens, and those are very common when a computer loses its power, and it's not uncommon. But we can see in there, you can see the light on the fuel pump relay, right? Remember what this computer controls is the relay that will turn on the fuel pump. But everything is working 100%. So I'm going to keep the computer running in here for probably, I don't know, maybe an hour to make sure everything is fine, and a start and a stop, a start and a stop multiple times. But I mean, realistically, the proof is in the computer already talking and running. We have a completely dead computer. Now it's a fully operational computer. All right, guys, thank you so much. I hope that you like the content. If you have a boat and you have a MEFI 4, MEFI 3, pretty much any computers, you're in the best hands, period. There is no other company in the world, and I can very surely, I'm very sure that no other company does what I do. The reason I say that is because I can show you what is happening before, and then the computer running, your computer open, doing the test, telling you about the voltage rails. I am an expert. I know these computers like the palm of my hand. I have back reverse engineer completely this board to where I start looking for voltage rails, and I know, oh, that is not repairable or is repairable. And in this case, that's what I was assuming in the beginning, that was able to be repaired, because I am very familiar with those rails when they give me those results. If you're here in the channel, don't forget to subscribe. That helps my small business tremendously. That's the reason you're able to find me, and it's for free. So if you subscribe, YouTube promotes more and more my videos, and that helps me a lot. So thank you so much if you do so. I will see you next time. Bye-bye.